Hi everybody, it's Miss Peachy from Physics, and we were trying to solve this problem in class, and we were struggling in class today, so I knew it was something simple that I was doing wrong, and I apologize because I have been very sick, so sometimes it's really hard for me to think around that brick in your brain when you've been sick, but I did figure it out. It's actually pretty simple, and I feel bad when I try to do things the wrong way for you guys and make things look much more complicated than they actually are, because they're not. But one of the things you'll find when you're doing your physics problems is sometimes it is something where you just have to play around with it a little bit before your brain kind of can work it out. And like I said, there's multiple ways you can solve problems too. So just because I'm doing it one way doesn't make it the right way or the only way. So let me show you kind of how this is supposed to work actually. So the problem said, excuse me, that you traveled 5 meters to the east, 8 meters to the north, and then 3 meters west, and then you wanted to figure out the resultant vector. That's kind of where we left off, and that's where we were struggling. So I'm going to give you a full screen of my notebook, flip it around for you to see, and kind of show you what I've been drawing. And you can see some smudges because I've been kind of working on this and figuring it out, and then I realized that I was being dumb. So the easiest thing here is that, we drew our vectors. I didn't use grid paper, but it would have been better if I had. And I labeled them. I didn't put units on there either, even though I probably should. And I was playing around with the space in here, but what I really should have been doing is thinking about my x-axis and thinking about drawing this line back to the y-axis here. Okay? We know this distance is 8. This distance is the same. It's 8. We know this distance is 5. We know this distance is 3, and if I'm going backwards, that this whole distance is 5. That makes this 2. Obviously, I didn't do a very good job of scaling this. So now we have really a pretty easy problem here. We need to find the resultant vector. And just by looking at this, I've got two sides of a right triangle. So I can easily solve for r. So 8 squared plus 2 squared equals r squared. Where's my calculator? Yeah, this is what happens. Okay, so got my calculator. Go ahead and solve this. So 64 plus 4 equals r squared. 68 equals r squared. Root 68. 8.25. Just way too many significant digits. So we'll call it 8.3. So that gives me r is 8.3. Okay? The other component of this is you need the direction. So you're going to need the angle here. And this is where SOHCAHTOA comes in handy. So we have all of the sides of the triangle, 2, 8, and 8.3. And we need this angle, theta. So, I could easily just go sine of theta is equal to 2 over 8.3. Inverse sine of 2 divided by 8.3. And then I'm going to pick my inverse function. So that gives me this angle of 13.9 degrees. So I could say it's 8.3 meters and 13.9 degrees east of north. Remember, that's the same as saying same as saying 76 degrees north of east, right? Because basically, and that's not right, 90 minus 13.9 times 7. Okay. So, basically the same thing. You're just figuring out the angle. So simple problem. Simple solution. We made it way more complicated than it needed to be. And the big takeaway from this is that you got to think outside the box. You know, you think about this as your space, but you got to think about the negative space too. And that helps a lot in this case. We actually were using the negative space to help solve for R, not the space itself. Hopefully that makes sense and a little bit easier of a solution for you. Again, apologize for the brain malfunction in class today, but we all have those. So if you have any more questions, let me know. Flippin' Physics on my website is actually pretty cool. It does have these short tutorials that work through problems and kind of goes through, you know, really good examples on how to do this vector math. And next week in class, we'll be doing some more of this, but we'll also be doing projectile motion. So it kind of even adds more complexity to this whole thing. All right, thank you guys. Have a great day.